Welcome G. Let's start another design pattern. So today I'm going to talk about the adapter design pattern, and this is the one kind of a software design pattern that help us, you can say, to make two incompatible interface or classes can work together. So here again we are going to discuss in the two part, on what theory say and what how we can write the code for that, how we can implement that. So let's start theory. So theory say if this adapter design pattern allow us two incompatible interface work together. This is the simple meaning as an adapter. So interface on existing class can be used to another interface, or you can say generally used to make existing classes work with the other without modifying underlying the code. So this design pattern just act as a connector between the incompatible interface. Okay, so let's have a interface 1 and interface 2. Some place your API need one interface, but you want to pass two, it can work or not. So adapter just make a kind of one uh, connector between this incompatible interface so that your application can work. And sometime it's a pattern also known as a kind of a wrapper patterns, just wrapping the one interface and what demanding. So this interface just allow us, if one API, one method are expecting a kind of interface, but you don't have a kind of interface, you have b kind of. Let's see, you have a one API that expecting a kind of interface, you have to pass here. Okay, but currently in your application you don't have a kind of implementation of a API. So let's you have a b kind of interface implementation, so we can use b here to invoke the or not. So adapter help us to solve this problem. Okay, adapter say yes, we can write adapter for a if take input of b type interface and make work compatible with the a type interface. So in this way we can help our application can invoke different kind of interface. So let's look basic example. So let us we have a one, let's just one static method, let's that can make API call, make API call. Okay, that's let they accept one. Let's give, we have a interface A. Let's we have interface A. Let's they have a define just like a void method. Okay, this is the one interface, and let's this API expect कि someone pass interface object. Okay, and after that this, let's assume it doesn't return anything, and just whatever the object there and just invoke a method. So here we have a so let us we have another interface. Let's we have another interface, let's go b, and b have a method like b. Now let's assume we have a one class that uh, interface b impl, interface impl implement interface, and let's override whatever the methods they have. Okay, interface b impl class. Okay, have this method. So here scenario is that now whenever you make any API call, you we need a interface a kind of object. But let's assume you don't know what kind of a implementation have. But currently you have only one implementation. Let's give we have a class object. This let us we have a interface B object. So here problem is that can I make this uh, function call with the help of object B or not? So currently this not allow. Reason reason this API call expecting anyone can invoke me with a interface of A. Currently you are trying to invoke the interface of B, which is incompatible. Okay, so here we have to kind of write adapter that make compatible between the interface B to interface A. That's how. So simply let's key class like adapter just adapter just implement a interface. Okay, reason why we are this class make API call expect ki you are passing the interface A, so you are just implementing, and whatever the dummy implementation just we have provided. So here you don't look at what the A implementation this, but currently you have a B interface implementation. So you just say I have a just placeholder here. Whenever anyone can construct me, just pass this object B object, and here say this dot be equal to object dot B. And you know whenever this interface make API call invoke method, from here we have a B object and I am going to invoke B object methods. So here you are working just kind of wrapper. Let's now I am not going to pass directly B, but I am say I am going to use my new adapter that will take the object of B and make the call happen. Now your API is happy. Your API is happy to able to they assume कि we are expecting interface A implementation. We can invoke interface A method, but really we have not implemented any class A, but we have written B adapter. This adapter say interface A adapter, they have a reference of existing whatever we whenever this interface A invoke A method, they are just invoking method B. And now if you run this code, it will work. It will works. So here what you are doing, here we are doing this methods expecting interface A implementation, but currently we have a not A implementation, we have a B implementation. So I write one adapter for implementation A. At that whatever the method they have, just override those method. From inside whatever the object have, we have a B object. So we just take as a B as a constructor and invoke the B object method. So one kind of things, we have a B object, we have a B object, we have just written one wrapper for A, and A have expecting object A method A, and we are just overriding method A. So adapter design pattern helps to invoke a particular method call that are expecting a different kind of interface, and actually we have a different kind of interface. So in this case you write just one adapter class, just wrapper class, just that wrapper class implement what kind of API expecting, and what you have just holder placeholder ki I have a B object, and what the method they are invoking, method A. From method A just invoke your original method what B object have. So in this way we are make incompatible call. So we have interface B, I want to invoke a method that are expecting interface A. How it's possible? Using the adapter. Adapter class just take input of B type interface and just return kind of make a call for A kind of interface, because this is a type of A, and here you can make call of A. From in that call we are returning method B call. So this is the very simplest way to write a adapter design pattern. So even easy, as a this interface, this interface have only one abstract method. So this is the candidate for you can implement a lambda expression. So why need to write this complete adapter class? Can we do without writing this adapter class? Java would say yes, don't need adapter classes. You can directly implement. This is the functional interface. Have only one abstract method. You can directly implement it with lambda expression. So simplest say, okay, I want to make API call. I don't want to write this adapter class. So if you think what in adapter class you are doing, you are just implementing this logic, overriding this function. So this is the logic you can place here itself. Why need a write logics? Just copy and place here. This is actual implementation and math. Just make a differences. Now this is just, now you are able to make a call. There is only one signature, just you overwrite it. So lambda expression make a so concise. Even you don't write your any adapter class. Now you are able to make call to a interface. We have only B implementation. Now you are able to call. So this is the way as a Java lambda expression help us to writing code as really needed. In this adapter class, what are you doing? We are just implementing interface A, what is expecting A, and after that you are holding the object what kind if you have. After that, in overriding method, you are invoking the byte B types of methods. So all these are all these are the code that are maybe not needed. In whole logics, you are only interested to invoke my methods. So lambda expressions say, yes, what your intention? You want to invoke the method B? So just write only those things. Rest, just leave it. So this is the way, if you are using the lambda expression, you can easily write your adapter. Even here look like what you are doing, maybe confusion. So best way you can write using the method reference. Just like let's key we have a one static method that let's key just call using adapter, call using interface A adapter. Just give the say doctor. You know what they are saying, whatever the you are just returning. Okay, I am call using method reference this way. And what now you are going to make more specific call. Instead of say I am going to using the method reference, I am just here. What are my sample class? Just and now we are able to make a call. So here be simple key call. Yes, we are able to call. Okay, so here what are doing? Say call using interface adapter. So here might be someone read this method, they doesn't understood what you are doing. Here is specifying key I am using the adapter. So lambda expression say key your code is so concise, but for readability you have to write valid more descripting your method name. So whatever you are doing inside here in the B implementation, you are just writing one this implementation. So why you are not giving the maybe right whatever the business logic you have, you currently B class you have the whole logic, instead of writing in a class you just writing the method. This method is invoked from here, and that is a be simple. Okay, so you are able to invoke without using your actual class implementation. So this is the help kind of benefit if your programming your API is depend upon the interface. This is a depend upon interface. Interface can be implemented using lambda expression, and lambda expression in adapter class using the lambda expression we are only this is the main business logic. So you are putting only the main business logic here. What do you really need it? You want to invoke the B methods, invoke B methods. So here our make API call is expecting to whenever anyone call just give me the interface A object, but we have interface B object, we are not able to directly call. So you are at adapter, or you can implement using lambda expression, or you can implement using method reference. So hope now you are clear. Adapter design pattern helps to invoke particular API call, particular method calls that have a expecting different interface object, and you have a different interface object. Using maybe adapter, maybe that new adapter class, whatever you're expecting and whatever you have, you just hold it, and from the overridden method just invoke what you have, and that can be implemented using lambda expression or method references. So it's so nice and concise. So that is the about your adapter design patterns. So now you are clear. Adapter just help one kind of input can be converted into the different kind of input. Yeah, means you are trying to say if your uh, API call are expecting A kind of interface, but you don't have implementation of A kind of, you have B. So can pass B? Yes, using the adapter. Just write between the adapter or wrapper. Oh, and you are able to call. So hope it will uh, give you some idea how adapter design pattern works, and whenever you are read and write the code, you feel you feel very comfortable to implementing anywhere where you feel some incompatible API call or method call happening. You can easily implement the one adapter there. Okay, hope it's helpful for you. Again here I'm like to say thank you for watching this video.